Today we're speedrunning Codeforces round 898, division 4. Its length is 2 hours 30 minutes, but I hope we will do it a little bit faster. Actually, it's 8 problems long, maybe. And if it is 8 problems long, this means that maybe it can take more than just like an hour. But I hope not. It fell off our phase of open hacks after the end of the round, not giving additional points. After the end of the open hacking phase, all solutions will be tested on the updated set of tests and the ratings recalculated. Have there been a lot of Div 4 rounds? Okay, in education rounds, if there is a 12-hour phase of open hacks, then after that they have a table of the most successful hackers. Let's see if there have been a lot of hacks. Not really. But some people hacked something. Okay, the round is starting. Oh no. Have some time yet. Is this person actually gray? I don't think so. Fine, let's start. Hmm. Okay, let's test it. Yes, yes, yes. No, no, yes. Great. But really slow. I think I will have like 2000s place. Or won't I? Okay, this is an easy problem. All we need to do is to add 1 to the minimum digit. Okay. First of all, we say that, actually I can copy it. First of all, we find the minimum element of n.begin, n.end. Okay, we take star and we increment it. After that, okay, let's do it long, although I think it's okay with int. Great. 16.2, 432, big power of 9 times 10. Let's continue. Some people already solved C and D. Okay, 10 times 10, isn't it? So here we do the following. We say that I'm not really fast, guys. So we need here VSV, and here we do the following. We go through int I from 0 to 10, from int j from 0 to 10, and if Vij equals x, then we need to add some points. How many points? Ans plus equals something. We return ans. So what do we add? We add like minimum of minimum of and minimum of. So which minima we take? First of all, we say that minimum of I plus 1 and 10 minus I, yes, and the same for j, plus 1 and 10 minus j. $17.05 220. Yes. My camera, for some reason, isn't working well. Okay, we continue solving problems now. D. You can take any k consecutive cells and make them all white. Great. This is an easier, greedier problem. So here we have a string. What do we do here? We say that we go through all the elements. And we say here that if Si equals black, then we say something like plus plus ans and I plus equals k minus 1. Great. To test that, Nice problem. A bit interesting. This is a nice one. So here we have some array, and we want to add water until while we can, actually. Great, let's try and solve it. So we have nx and ai. Great. So we want to find the maximum h. Actually, we can just use the binary search and not bother about everything else. It is a bit slower than the linear solution. There is a linear solution, but we will use the binary search. So the minimum possible h is of course 0. And the maximum possible h is of course like x plus 1, and it is actually not possible. Okay, while y minus x is greater than 1, we take the mean value and we go through all the numbers in vector v and say that a plus equals maximum of 0 and h minus v, h minus I actually. And then we say that, what's wrong with you, M? And then we say that we return x, and if a is greater than x, then we cannot. So if a is greater than x, then we cannot use so big aquarium, so y equals m, else x equals m. Actually, I was wrong. Y is not x plus I. Y is like what? It's like 10 to the 9th plus 10 to the 9th. I believe it is 2 times x. Okay, let it be just 2 in 9. That's it. In this case, we need long here. Great, we are fine now. No, we are not fine. What's wrong with you? So it said that I can make aquarium of height 9. But I can't. Let's see into this function. Let's look into it. So we have v. So for some reason, if m is like between 4 and 9, something wrong happens. Okay, 7. So it says that 7 is okay. Let's look into I and I. A and I. And what is x? X is 9. Okay, so if a is greater than x, and it is... Oh man. Hate this. 442, 335. Yes. I've already spent so much time. My lord. It's good enough that I'm not a Division 4 person, and this is not rated, because if it were rated, I would, like, lose a lot of rating. Here. Like, where am I? 58th. Gross. Luca is in front of a row of entries. Has AI fruit and height HI. He wants to choose a contiguous subarray that each number is divisible by the next one. So we need the maximum length of a subarray, where each number is divisible by the next one. Okay, this is two-pointers problem this time. So what do? We take nk, then array A, then array H. We find ans of AHK. So we have the biggest, we have actually current segment. And in the end, we return ans. So what do? We go through all the elements. Okay, so what do we do here? We try to add 1 to y. So we say that y equals I plus 1. We try to do it. So if I equals 0 or hi minus first is not divisible by hi, then we cannot afford it. And we say that, sadly enough, we have to say that x equals I. And also let's look at our sum of all numbers. So we say that x equals I and sum equals AI. Great. Otherwise, we just say that sum plus equals AI. And after that, we say that while sum is greater than k, we need to subtract the leftmost number. So we say that minus sum minus equals a x, and we increase x. After that, we say that ans equals maximum of ans and y minus x. 3 to 1, 0, 3. Cool. Oh no, I have wrong answer test 3. Problem E. This is really not good. Everything is lagging. Why is F still not tested? Okay, now we're fixing problem E. Let's look at what could go wrong. I get it. I think it's 2EI, 2E9 plus 2, for example. Okay, this is really stupid. Let's reset meet. Yes, let's reset meet it. What's going on? It's not what I need. The queue is so huge. You're given a string S made of characters A and B. Pick substring AB, change it to BC, and get a coin. Also, we can take BA, change to CB, and get a coin. So the number of coins is no more than the number of A's in the string. Actually, we take all substrings. Yes. Yes, we are ready. So here we only have const string s. And here we have accepted. Okay, so what we need here is we need to find the sizes of all blocks of A's. Actually, there is some way of doing it with modern ranges, but since I do not have modern ranges, I will do it old style. So we have current block of A equals 0. We have sum of all blocks A, which is also 0 initially. And we have also minimum block, which is 1e9, for example. And of course, we want to have number of blocks. No, we do not need it actually. So let's go through all. I think we can do char C from S. So if C equals A, then we add it to the current block. So we say current A, sum A, otherwise we say that minimum A is minimum of minimum A and current A. We say that current A equals 0. That's it. In the end, we also say that minimum A equals minimum of minimum A and current A. And we say that return sum A minus minimum A. Right, that's it. 21316200. All zeros actually. This is because these should be big characters. Correct. Problem H, finally. Is it wrong on test 5? No, I believe it's not. So we have the following problem. We have two pieces of plastic on a graph, directed graph. No, two-way rod, so on a usual graph. And first of all, the first person chooses where he moves his piece, then the second person chooses where he moves this piece, and if they go to the same vertex, then one of them wins. Okay, let's think. I think I would like to draw something here. So, how can we win? Of course, can person stay in the same vertex? Or stay in the same building? Marcel wants to catch Valerio. So again, actually, Marcel is catching Valerio. So first of all, Marcel chooses some vertex, and then Valerio chooses some vertex and goes there. Actually, if there is a cycle and Valerio can reach it, okay. Let me think. So there is a known problem that if Valerio is in a tree and Marcel is also in a tree, then Marcel can catch Valerio because eventually Valerio, Marcel, what he does is he continuously decrease the area where Valerio can be until it's a single leaf. Okay. Problem is, if there is a cycle and Valerio is onto a cycle, then actually he can escape indefinitely. So assume that he knows where Marcel goes. So if Marcel goes into Valeria, Valerio chooses any vertex neighboring to it. If Marcel is going to a neighboring vertex, Valerio can stay in the same vertex. And if Marcel is already on the cycle and he goes after the Valerio, Valerio moves next to in this cycle. So the question is, can Valerio reach a cycle before Marcel catches him? Yeah. So we consider, I guess we consider all vertices. We consider all vertices on the cycles. And I think we just need Valerio to reach some of these vertices before Marcel does. Yes, I believe this is the correct solution. So the only thing that Valerio needs is just to reach some cycle. That's it. Before Marcel does the same thing. Okay, so assuming that we are in some tree and we are not on the cycles, what does it mean? It means that actually we are in articulation point and all these parts are disjoint. Okay, but in this case, we actually know where we go. We go to the part with cycles. And Marcel does the same thing. Actually, we continue until we reach a cycle. Okay, if there are several cycles, then Marcel always wins. Valerio always wins. So we take Valerio. We consider all these subgraphs. So if there are at least 2 vertices here, then Valerio is already on the cycle and he wins. So otherwise, he is not on the cycle and he is in articulation point. In this case, he should choose a part which contains a cycle. If there are at least 2 of them, then he wins, assuming that there is only 1 of them. Okay, then if Marcel is here, then Valerio wins because he escapes. So now let's assume that okay, I get it. I get it. So we just need to find like we need to find all vertices. The first vertex which is in a cycle. That's what we need. Okay, how is it done? I actually don't remember. So I believe we run some DFS. I believe we run some DFS. Okay, so assume that we have found some edge. In this case, all these vertices are some cycle. Yes, okay, this is a DFS problem. Actually, it's been a while since I last time wrote a DFS, I believe. So NAP. We immediately decrement A and B because we want 0 indexed numbers. Then we read the graph. Ah, actually there are n rods between them. Okay. And the rods means that there is only one cycle. And rods means that there is only one cycle. So the graph looks like this. There is a cycle and there are several trees coming from it. So what Marcel needs is he needs to visit this vertex before. Oh, what Vincent needs? Valerio needs to visit this vertex before Marcel does it. Okay. Find answer of E, N, A, and of course N. I actually will not need that E is the number of edges is the same as the number of vertices because I cannot use it actually. We also decrement E. Before that we read E. And here we say bool. And here we say yes or no. Did I get accepted? Yes, I got accepted. So here, first of all, construct G. Yes, I construct G. Then I go through So I say int target equals a pair target distance equals DFS of, where is Valerio? Valerio is in vertex B. So we run DFS from B, we need G, and we need V, where V is visited, which is false. So pair int DFS current vertex, the graph, and the array of being visited. So actually I also want to have the array of distances. So like PIH. So here we go through G of U. And also I want to keep track of parents. Yes, I need to keep track of parents. So here I pass -1. So if p equals 2, then continue. After that, if okay, I want to first get distance and then target. And the distance in beginning is 1e9 and the target is -1. Okay, if actually still c1 equals 1e9 and here I use c. So if after if visited of u, then I want to say that I found a cycle. So I say that answer equals minimum of answer and some other pair, which is the distance, which is h2, and target, which is 2. Okay. So if this is if u is visited. And after that I say continue. Otherwise I say that ans is minimum of ans and DFS of 2 u g visited and h. And also I want to say that h2 equals 1 plus h u. In the end I say return ans. So what did I do now is I constructed the distance and the target. Okay, here I also want to say that VU is true. Visited U is true. I don't. I actually want to put it here. Visited U is true is here. Great. So now what I want is to say that int a distance equals distance between defined dist between A and target in graph G, and we return that distance is less than A distance. So the only thing left is to find distance. And we can do it via a BFS. So we say Q int U, vi distance of size n, constant n equals g dot size, while true, while q dot empty, while it is not empty. We say that int current equals u dot front, u dot pop, if I can say here that if q equals we return 0. Here I say q dot push a. No, q dot push u. Then I go for int 2 through, can return c actually. Go through g of current, and if here I also say and c, and here I can actually return, okay, c is okay. So if distance 2 is c, then I say that distance 2 equals distance current plus 1 and q dot push of 2. And if 2 equals v, return distance 2. Great. I believe it is done. Yes, no, yes, no, no, yes. This is not correct. Let's look at the example. For example, this example. Okay, for B, target should be 0. So this is not correct. Let's look. So here we have u equals 0, and I want target to also be 0. It should be 2. Yes, no, yes, no, yes, yes. No, 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 yes, actually. So this is incorrect. We are going to need to draw this graph, I believe. So here we have 8, 3, 4, 6, 2, 1, 5. Seven, 6. So, and this is we, and this is Marcel. So the answer, what? Marcel is A, so Marcel is 5. Yes. I believe that green can escape because he can escape because we go here and Marcel goes here. Okay, let's look at this. What does it say? No. So it says the distance equals 2 and target is 5. Yes. Now we need to find the distance from 4 to 5. Yes, and isn't it 2? Yes, it says that it is infinite. Ah, distance of u equals 0, of course. What? How did it complete all these tests? I don't understand how it completed all the tests. Fast, I mean. Yes, no, yes, no, no, yes. Fine, we believe that is correct solution. Submit it. Fine. Okay, spent almost an hour. Okay, let me explain the solutions. There are 3 cards with letters A, B, and C in some order. You pick 2 cards and swap them. Is it possible that the row becomes A, B, C after the operation? So what it is said is you have a permutation of 3 letters, and you're asked if it is possible to make at most 1 transposition and make ABC. Actually, there are only 3 factorial equals 6 permutations, which are ABC, which are listed here. I can write them here. So what you can do is you can actually read a string, check which one of these 6 it is, and for this 4 you print yes, and for this you print no. What I did is I checked if there is at least one letter which is on the same place as it needs to be. So if there is like an inertial letter which is on the same place in ABC and here. So you check that S0 equals A, or S first equals B, or S second equals C. Or any other solution that you can imagine for discriminating between these two sets of strings. Good kid. We have an array A of n digits, and we present, and we want to find the product of these digits, but we can add 1 to exactly one of these digits. And we want to maximize the product. So you have digits A1, A2, etc., AN. Assume that you added 1 to AI. So now you have A1 times A2 times etc. times AI plus 1 times etc. times AN. So let's apply distributive law, and we see that this is just A1 plus etc. plus AN, and the same thing, but without the AI factor. So this is constant, and you can calculate it in the beginning if you want. And this is maximal if the biggest numbers stay here. Yeah. So what you want here is to have the biggest n minus 1 digits. So you have n digits, and you want to choose the maximum n minus 1 among them. What you really need to do is to choose the minimum one of them and remove it from the product. So here you have the constant, and here I have product from which you need to remove just the minimum digit for it to be a maximum. So after we have understood this, we do not need actually this expansion. We can work with this one. So what we need to do is we need to find the minimum digit, add 1 to it, and then multiply them all. And you will get the correct answer. As for constraints, the maximum answer is like 10 times 9 to 10th, and as you can see, it is okay. It is within the bounds of int, so you can actually use int, but I used long just in case. Problem C. So first of all, you need to read all 10 strings, and from each of them you need to iterate over all chars. So assume that we are looking at char ij, where I is from 0 to 9, and j is also from 0 to 9. So if Cij is dot, then you do not need to do anything because this sector is untouched. You do not add any points here. So nothing. Let me write it as pass. Else, you need to add to answer some function of ij, where the function is the number of points depending on the position. So how do you calculate the function? So if you see, if you look carefully, for example, let me draw it for 6, okay? What you can find here is there are 6 linear segments here. Let me show you. Oh, sorry, did it incorrectly. So here I repeat this pattern, then I go for this pattern, and finally I go with this pattern. So what we can see here is we have several linear functions. For example, let's look into this trapezoid. The function here is actually just if there's 0, 1, 2, 3, 4, 5, this is 0, 1, 2, 3, 4, 5, and this is axis I, and this is axis J, then the function here is 6 minus I. It's simply 6 minus I. Okay, Also, we have this part. This is a triangle. Here, the answer is 6 minus j. Also, you have this part, where the answer is I plus 1. And finally, in this part, the answer is j plus 1. And you can notice that actually always the minimum of these four numbers is chosen. So what you need to do is choose minimum of I plus 1, j plus 1, and I chose 6 before because the size of the matrix is 6, but in our problem is 10, so 10 minus I and 10 minus j. So this is the function which calculates how near center you are. And this is what gets you accepted. Let's continue. Problem D. You're given a strip of paper S that is n cells long. You can take any k consecutive cells and make them all wide. Okay, this is a greedy problem. What I want to say is that if you have some string, you're choosing where will we apply the first operation of erasing. And what I want to say is you put it rightmost. You want to destroy the leftmost B, and you choose the rightmost position which achieves this. What do I mean by that? Assume that you have W's here. Then actually, you don't need to erase there. Why would you need that? They're still white. So if you, for example, have some window of erasing which intersects with these Y's, you can move it to the right. You do not mess up anything here, because they're still white. You do not mess up anything here, but you start to erase this cell. So this cell wasn't erased, but it is erased now. Or as it's called. So it becomes erased now. So it's better for you to erase more cells than before. So critically, you just need to, if you see this B, which is the leftmost B, you make this erasure. So assume that we have already applied this erasure. So now all these things are just white. But let's then continue. We find the next B, and actually we do not need to do this. Because if we do this, these cells which are covered by this erasure are already white, and we do not need to make them white again. So what we would like to do is move it to the right until this is the left edge of the operation, because you add several more elements to be erased. Finally, the solution is as follows. So you go through all chars of your string, and if the current char is white, then you continue, because you just move to the right. Otherwise, you say that answer is increased by 1 because you need to apply this operation. But now you do not need to look at all these elements. So you are in the beginning of this block, you can just teleport to the end of this block, because all of this will be just white. And after this increment operation, this position will be moved one more time to the right, and you will go to the next area. So how to move from the beginning of this block to the finish of this block? So the block is of length k. So you need, if you add k, you just move to this position. So you need to add k minus 1 to get to this position. So plus plus ans and I plus equals k minus 1. And this will be the solution if you return the ans in the end. Continue. Problem E. This is a problem about aquarium, and this is a simple binary search. So assume you chose height h. Then in the if height column, you will get maximum of 0 and h minus ai of water. So let's sum these things, and in O of n time, we will get O of f of h, where f of h is the amount of water, assuming that the height of the aquarium is h. So if f of h is greater than x, this means that answer is less than h, because you cannot take this size of aquarium or bigger. Otherwise, ans is at least h, because you can do it. So this is a predicate which you can check in binary search. So you say that minimum possible is 0, because you can take the aquarium of size 0, you will just have no water there. And minimum impossible is what I messed up during the contest. This is the minimum size of aquarium, which is impossible. So how to calculate it? You have 10 to the 9th water. You also have 10 to the 9th coral. So if you take exactly 2 times 10 to the 9th, this is actually a possible answer. Sometimes it is true when you have only one column. There is a coral of size 10 to the 9th, and there is 10 to the 9th water. So this is the maximum possible answer. Minimum possible answer is this plus 1. So these are bounds of the binary search. Then you say that while minimum impossible minus minimum possible is at least 2, this means that you still need to do some iterations of binary search. You say that int h equals half of the sum, and beware that it can be big. This can be up to 10, up to 4 times 10 to the 9th, which is not in int. You can use unsigned here or long. Because otherwise you will get 2 times 10 to the 9th plus possibly another one 2 times 10 to the 9th, which is about 2 to the power of 32, a bit less, but still it cannot int cannot contain such big numbers. So we calculated it, and then we check if answer is at least h, which you can check by this procedure as I explained. Then you say that minimum possible is h, else minimum impossible is h. So this is the end of the binary search, and you return minimum possible. Problem F, money trees. This is 2 pointers problem. So you have an array and h and another array a. You need maximum length of segment LR such that AI divides AI plus 1. Yeah? No, AI is divisible by AI plus 1. And actually H. I plus 1 divides HI. For I from L to R exclusive. And sum of all A, L plus etc. plus AR is at most K. So these are 2 things that you need to keep track. And what you can notice is if you shrink this array by 1 from any side, and the condition was true, then it is still true. So assuming that you shrink by 1, then you just remove one constraint of this type, and also you decrease this sum. So if it was at most k, then it's still at most k. So if we have, like, let's draw a 2D diagram where this is where we put L, and this is where we put R. And these points correspond to the beginning and the ending of the segment. So this is all possible segments where L is at most R. And as I said, the area of all possible segments here, it looks like it's like some sort of horizontally and vertically convex. How to draw it? So first of all these segments are okay. And it looks like this. This convex green area. What do I mean by horizontally and vertically convex? This means that if you are in green, you are moving horizontally, there is a segment which is green, and all except this segment is black. And for vertical, it's the same. All this is green, and all the center is black. For example, this set, this is not neither horizontally nor vertically convex. Because, for example, for this line, you have two segments and not one. And for example, this one, this is vertically convex, but not horizontally. Yeah, you have all these vertical lines are segments, but there is this horizontal line which intersects into two segments with this green area. So this statement is convex horizontally and vertically in our problem. And this means that we can use two pointers. So what two pointers does, and is it traverses over this border. So we are in some point, we are in some segment LR. We are trying, can we move to the right? Can we increase R? If we can, we move to the right. Otherwise, we can always move down to this diagonal. And we do it. So maybe we move to the right, and we move down as far as possible. Then again, we move to the right, and we move down as far as possible. How can we move to the right? We just need to check whether this condition holds. And then we need to go down, and we need to increase L while this sum is still greater than K. And if this is not divisible, then we instantly make L equals R, because even L minus 1, R minus 1 and R are not okay, because there is no divisibility. Like we have L, R, and sum. So we do the following in the cycle. We say plus plus R, sum plus equals, let me do it like inclusively. So we have L and R inclusive. S plus equals A R. Yeah, and if if HR is not divisible, does not divide HR minus 1, then we have to say that L equals R minus 1, and just not L equals R, and just S equals AR. And then while S is greater than K, we say that S minus equals AL and plus plus L. And in the end, answer is maximum of answer and r minus l plus 1. Then return ans, and the cycle goes not while true, but while r is less than n. Minus 1. So this is solution. Problem G. So what you needed to understand is there are several segments. So let's look at all B's. Between each of B's, there are several A's, maybe 0. For example, there are 3 A's, there are 2 A's, there are 0 A's, there are 2 A's, 1 A, 1 A. And what you can do is you can start moving B to either this direction or to this direction. So, for example, BAA goes CBA goes CCB. So B like eats A's and produces C from the other side. What you can notice is the best thing to do is to choose some block and simply ignore it. So you choose a block, and all B's which are to the left from this block go to the left and eat all A's, and all B's to the right from this block go to the right and eat all A's there. So it is easy to prove that you can convert all A's to C's except one block. And this is any block that you want. For example, if you have the leftmost block and you want to ignore this, then all B's just go to the right. If you have just only A's, then there is only one block of A's and you have to ignore it because, well, you have to ignore only one block and you have only one block. So again, the same idea as in the second problem, I believe. If you have several numbers and you need to maximize the sum of all except one, then this exceptional number should be minimum. So what you do is you look at all blocks, find the minimum block of A's, and return number of A's minus length of minimum A block. This can be done just in linear time with a cycle. Not a very huge implementation. Fast. And the last problem is MATCT. So the problem is as follows. You have graph where V equals N and E equals N. So if V equals N and E equals N minus 1, and it is connected, also it is connected, then it is known to be a tree. Let's for now solve the problem for a tree. There is a vertex in which there is Marcel and there is Valery in some other vertex. And in the beginning of each turn, Marcel chooses some vertex, then Valery chooses some vertex, and then they go to these vertices. And if they met at the road or at a vertex, then Valery loses. The aim is to understand if Valery can escape Marcel. So actually, in case of the tree, the answer is always no. Valery cannot escape Marcel because Marcel can consider his... So assume that Marcel is a root of a tree of height h. Then actually he can choose the subtree where Valery is and go there. And now he can eliminate all this part of tree because Valery couldn't escape in this part of tree. So now he is a root of tree of height h minus 1. And if he continues to do it, eventually he becomes the root of tree of h equals 0. And this means that he catched Marcel. So for trees, the answer is always no. What about V is n and E is n? What is this graph in which the number of vertices is the number of edges and it is connected? Actually, it's almost a tree. It's a single cycle, and in each vertex there is also a tree. maybe empty tree, but still some tree. So now we need to solve this problem in this type of graph. So assume that Valery is already on a cycle. Then actually he wins, because if Marcel is not going to touch him, then Valery can just stay in the same vertex. If Marcel is going to touch him, then Valery can visit either this vertex or this vertex. One of these solutions might be infeasible, because Marcel can be, for example, here. But in this case, Valery can go to the other vertex, and so he escapes in this direction. So like a greedy strategy, if you have an immediate threat, you do something, and if you do not have an immediate threat, you do not nothing. You don't do anything. So this is if Valery is already in a cycle, then the answer is yes, he can escape. If he is not on the cycle, then actually he wants to get to the cycle before Marcel catches him. So if he's in some tree, then the only thing he needs is to get to this vertex. And this means that the only thing that Marcel needs is to get to the same vertex. So first of all, you need to find this cycle. If you have a graph with only one cycle, you can find it using DFS. What is DFS? You are in some vertex, you iterate over its neighbors, and you run DFS. So if 2 is not parent of V and not visited 2, then DFS of 2. So what we are interested in is the case that 2 is not parent of V, but it is already visited. The only way it can be is that we have some visited vertices, and then we went to already visited vertex. This means that this is the cycle, and since we have such graph with only one cycle, this is the only cycle. So this is the way to find the cycle and locate all its vertices. Then you need to find the nearest vertex of this cycle to Valery. It's actually the only one vertex, because if there are two vertices, then there is another one cycle. So after you've done it, you know this vertex, which I call a target. And you know the distance between V and target. So assume that Marcel is in vertex U. Then you also need to find the distance between U and target. And it can be done via BFS, or you can just assume that you go this way or this way. So counterclockwise or clockwise through the cycle. There are only two ways, so you check each of them in linear time. So you check these. And if d of V and target is less than d of U and target, then Valery can get to this vertex strictly before Marcel. So now he is on the cycle and he can run away. Otherwise, he cannot. Because Marcel gets to this point. He gets to this point. Valery is still into this tree, and now Marcel can run the strategy which I explained to you before that. So that's the end. Thank you. Let's look finally at the standings. I guess I'll be like 40th or 50th, something like that. Yes, I'm 48th. I think I will stay like the same. Of course, I failed problem E, but this is because I chose the wrong bound for binary search. Okay, fine. Thank you for watching. Bye.